Okay, 6.3b. And again, we're on top of page 517, rationalizing the denominator. In the last video, I had made mention that that equals, and I also said that when we're done, when we have our final answer, we cannot have a radical in the denominator. So what we have to do is get rid of that. And the way to get rid of that is to multiply the top and bottom by that radical. Because what does that do? That gives us square root of 3 times the square root of 4, which equals the square root of 12, but we're not going to write it that way right now. And the square root of 4 squared. Now, one of the things that's really, really important to understand, this exponent and the index, or the number that goes here, have to be the same. If they're the same, then this, all of the peripheral stuff to that 4 changes. This goes away, parenthesis goes away, everything goes away if that's the case. But the only way to make that happen is if this number and this number are the same. And then you take everything away from the 4 and leave it naked underneath the sign there. Okay, so that being the case, we have then 4, and square root of 4 is 2, and square root of 3, can't do anything, so that stays like that. Now we have a 2 over 4, which is the same as 1/2. And then we don't even need the 1 there, so the square root of 3 over 2. Okay, so let's look at square root of 5, 6, which is example 6. Square root of 5, square root of 6. Okay, we can't have that square root of 6 there, so we're going to multiply top and bottom by the square root of 6 over the square root of 6, which is 1. So you're not changing the value because you're just multiplying this fraction times 1, just a different form. Gives me the square root of 30 over square root of 6 squared, which means everything goes away, and we're left with that. Okay, let's keep going here, rationalizing the denominator for number 7. So we're going to multiply and get that. And the 8th one, so again, we're going to multiply it by and the one thing about radicals is you can multiply everything. You can multiply 3 times 5 is 15 and put the x and y together under one radical. Only with multiplication though. And these two, that goes away. And we're left with that. And that's as simplified as we can go. We cannot reduce this 15 over 5 to 3 because this is not 15. This is the square root of 15. So this number here is some number close to 4, but not quite. So can't just reduce that because it's a square root of 15, and 2 over 5 does not reduce. Okay, so here is where my mention of remember what I said, in order to get rid of the peripherals, in order to get these two, the 5 and the y, to go away, the exponent and the index have to be the same. And then everything goes away except the 5y. And that brings us to this one that we're going to look at right here. And I need to take my dogs for a walk, so let's go ahead and stop here and continue with example 9 later. So here we are, example 9 on top of page 518. And if you remember from the last example, one of the things that I had mentioned is in order to get rid of this denominator here, the radical in the denominator. And this 3, by the way, is the index. It's not in front of, it's in this little valley there. Anyway, in order to simplify this gets to be really, really complicated, so I'm trying to figure out a way to make it easier to understand. This cubed root of 4 has to be cubed. Okay, if that's cubed, then all of this goes away. So notice how I have the 3 there, or it can also be up there. It doesn't really matter, it's going to do the same thing. But this has got to be the same in order for it to go away. So right now we have a 1 here. I need 2 more. So what I'm going to do is I'm going to multiply the top and the bottom by those 2 more. And it has to be the cubed root of 4 squared. So when I do that, I get 7 cubed root of 4 squared. And that's going to be over 4. So when I did that, you notice how all of the cubed roots and the root and the squares, everything disappeared. And we're just left with a 4. All right, so now we're not done yet because we still have kind of a mess up here. And sometimes you're left with that mess, but in this case, I see that this 4 to the squared is actually 16. Or this 4 to the squared, I'm going to put it down here just to show you, can also be 2 squared, or 2 to the 2 times 2 power, 2 to the 4th power. So that's what I'm going to do, is I'm going to put, I'm going to put 7 cubed root of 2 to the 4th power there, all over 4. All right, so why did I do that? All right, let's move this over. The reason that I did that is because I've got a 3 here, and if I can get this number in here larger than this, I can pull some of these 2's out of here and simplify it more, okay? Whereas if I left it like this, it's not simplified. It's kind of like a fraction. 2 over 4 is not being reduced to 1/2. We don't want that. All right, so if you remember, what I said is I'm going to put 7 there, and I'm going to have a cubed root. And remember, I was looking to see how many times 3 will go into that. It goes into it 1 time. So I can pull one of those 2's out, and I have 1 left over, right? So I pulled out, how many times 3 goes into 4? Once. So I pulled out 1, 2, and I have 1 left over. Now, this is where it gets important for us to do what we did, because now I can cancel that. 2 over 4 is 1 over 2. So now my answer is 7 cubed root of 2 all over 2. So this looks a lot cleaner than what this looked, 7 cubed root of 2 to the 4th power over 4, or even this one. It just looks a lot cleaner by dropping it down here, reducing the cubed root of 16 down to the cubed root of 2, and it just makes it look better. So anyway, I do it a lot different than what the book did. And if you want to look at what the book does in example 9 and follow that, that is well and good, but I kind of like the way I do it. So either way, when you take a test on this, either way that you do that is fine. All right, let's go to example 10. 12x to the 5th power y cubed. And we're going to put that over 5z. And that has the square root. And what we're doing is we are simplifying this. Now, the first thing you're going to do when you simplify this is you're going to change this to 12x to the 5th y cubed, square root of that, over 5z, square root of that. So by separating the two there, we can simplify the top, simplify the bottom, which we can't do. That's as simple as we can go. So we can simplify the top and make life a lot easier on us. So again, I simplify differently than what the book does. So if you remember, what I do is I try to find two numbers, multiply together to give me 12, that I can take the square root of one of those numbers. Then I've got x to the 5th y cubed. So I just split that up, and I can take the square root of 4 and get a 2. So I'm going to put that 2 out here. Okay? Now I need to look at my x to the 5th and y cubed. Okay, so remember this index, if I don't put one in there, it's an assumed 2. So how many times does 2 go into 5? It goes into it twice. So I have x squared. Make it a little bigger there. So x goes into it, 2 goes into 5 twice with 1 left over. So that's no longer a 5, it's a 1 left over. I'm going to do the same thing here. How many times does 2 go into 3? It goes into it once, and it has how many left over? It has, 1 left over. So therefore, I have my 2, let's go ahead and rewrite it, 2x squared y squared, square root of 3xy, and then on the bottom I have this 5z here that could not be reduced at all. So I just leave it as the square root of 5z. Okay, so if you remember, you're not allowed to have a radical in the denominator. So we're not quite done yet. We have the answer simplified. We just have to multiply top and bottom by the square root of 5z over the square root of 5z. And when we do that, that gives us 2x squared y times the square root of, okay, so this is the nice thing about radicals. We can multiply all that together. We just put it all under a square root sign. 3 times 5 is 15. X, that's not an X, X, Y, and Z. We just take these two and this one and stick them together. And that gives us 5Z on the bottom, because when we multiply by whatever's on the bottom here, it works easier when this is index is 2, like that last one. When the index is 3, it's kind of a pain. But when it's an index of 2, it makes life so much easier. So that gives us, well, actually, I told you we're going to take the radical sign off. This is what happens when we multiply 5z times 5z. We get 5 squared z squared, which is, and there's a 2 there. So remember what I said, this number and this number, once they're gone, then all of the stuff around the 5z goes away, and we're just left with the 5z here. So that's it for number 10. And that's it for 6.3b.